Now, understanding the central processing unit. I am your trainer Jovan, and welcome to this topic. Now, the central processing unit, some people call it the CPU. This is the computer control center that consists of the processing and the main memory device, and it is always housed inside the system unit. So that system unit, the one you are calling hiyo nyumba mnaitanga CPU, inside it is where we have the central processing unit. And that nyumba, we call it the CPU, is not the CPU, it is the system unit. The system unit contains the electronic circuit that performs the actual processing, and the main memory that supports it by holding information that are required for processing. Collectively, it is known as the processing hardware, or some people call it the motherboard. So the motherboard is where we will find what we call the processing unit, the CPU. Now, at the heart of this hardware lies the central processing unit, CPU, which works along with other arithmetic and logic unit and another thing called the control unit. So the arithmetic and logic unit will help us in handling mathematical operation. The control unit will coordinate the other activities, process activities in a computer, while the other parts that work with it, the other components, they are going to work with it to form the brain of the computer, and that brain of the computer will perform execution of instruction and perform calculations that makes computing possible. Now, the central processing unit, it is the computer brain, just the same way we have said. It is the brain of the computer. Now, some people will ask, what is a computer central processing unit, the CPU? What is the CPU? The CPU is the electronic circuitry that controls the interpretation and execution of instruction. The function of this CPU is that primary function is that it processes the data according to the instructions that the user has given, or the instruction that has been stored on the memory. Now, what are the key components? It works with the following components. It works with the arithmetic and logic unit, some people call it the ALU, and it also works with the control unit. The control unit will always coordinate the activities of processing within a computer system operation. The arithmetic and logic unit is going to solve mathematical operation, and all these two components will help in execution of programs. Now, the CPU serves as the computer command center. Its work is to interpret programs, instructions, and process data. It coordinates all the computer operations by communicating with the hardware components, mostly with the hardware components, to ensure that the tasks are completed effectively and accurately. The arithmetic and logic unit. What is this arithmetic and logic unit? This arithmetic and logic unit will help us to perform fundamental arithmetic operation or mathematical operations, and is composed of two distinct sections that handles different types of operation. As a critical components of the CPU, the ALU will execute all mathematical and logical operations required by the program to run on a computer. So the ALU works directly with the control unit, which works by receiving instructions about which operations to be performed and what kind of data is to be worked on. The results that comes from the operations of the LU is that it results from those operations that are stored temporarily in the register before being sent to the memory, and they are used in subsequent calculations. The ALU will perform a basic operation. Basic operation will include addition, subtraction, and multiplication, and also division. This is the mathematical operation, or the arithmetic operations. It will also sometimes perform what we call the complex maths or complex operation, whereby it will handle advanced calculations through combinations of basic operations. Now it performs using what we call binary, and that leads us to what we call binary processing. The arithmetic and logic unit will perform binary and perform all calculations using binary number systems. As you advance in ICT in future, you will know how the binary numbers are done, especially when you are performing a unit called basic electronics. The arithmetic and logic unit is a section of the ALU that performs calculations such as addition, multiplication, subtraction, and division. Now, it processes numerical data at an incredible speed, enabling the computer to handle everything from a simple spreadsheet calculation to a complex scientific simulation. Now, the logic unit, this is where reasoning occurs. The logic unit or the decision making unit, this helps in decision making, and equal to will determine if a value matches exactly what is there. The greater than will compare whether a value exceeds another one, or less than, greater than, or equal to. It will also perform a Boolean operation, that is the true or false, whereby we are going to evaluate the Boolean condition. Then the less than, it will check if a value is smaller than the other one and give you an output based on what it has found. The logic unit will perform comparisons such as true or false, that is the Boolean, greater than or equal to, less than, and many other logical operations. These logical operations forms the basis of decision making in a computer program, and they will enable the conditions of execution of instruction to be based on a specific criteria. Now, the control unit. What is the function of the control unit? The function of the control unit is to fetch, meaning that it is going to retrieve instruction from the memory. Decode, meaning that it is going to interpret the instructions that it has fetched. Execute, it is going to perform the required operation according to the instructions that it has decoded. And then it is going to perform storage after the output, or after processing, or after execution of the instruction, meaning that it is going to save the results back to the memory. These results is always stored in the secondary storage. Now, the control unit the control unit will always process instructions and data in the computer and transfer them into the arithmetic and logic unit. It acts as a traffic controller by coordinating the flow of information between the CPU, the memory, and the input/output devices. That is just the work of the control unit. It is the coordinator, in short. Now, CPU instruction cycle. We've talked about the CPU instruction cycle, and we have the first cycle called the fetch. The fetch will help us to control or retrieve the next instructions from the memory so that it can help us in processing. After we have fetched, we are going to decode. Decoding is that we are going to interpret that instruction to determine the required action. After we have done decoding, we now go into the real processing, and that real processing is what we call execution. In the execution, the arithmetic and logic unit performs operations of the specific instruction that has been given, or even the logic unit performing the operation or determining which operations to be done. Then after which, when we are done, we are going to perform the storage, whereby we are going to store the results. We store the results by rewriting them back into the memory. And which memory is that? Secondary storage. Or we can decide also to output that the same information that has been processed out on the screen or on a paper. So the CPU continuously repeats these 4 steps for each instructions in a program. Modern CPUs can process 1 billion of these cycles per second with techniques like pipelining, which allows multiple instructions to be in different stages of the cycle simultaneously. You can imagine how that thing is very powerful. Now, the architecture of a CPU or a processor. The architecture of a CPU, this is how it looks like. In a CPU, we have what we call the registers. The registers are small or ultra-fast memories locations within the CPU that offers temporary storage of the data being processed, meaning that it will always store what we call the program counter and some other details of a given process. Now, inside the same CPU, we have what we call the cache or the cache. Some people call it the cache memory. The cache will offer high-speed memory to store frequently accessed data to reduce the access time when we are working with the CPU. Then we also have what we call the buses inside the CPU, or on the motherboard there are also what we call the buses. And these buses, they are the interfaces, the bus interfaces. They help us to connect the CPU with other components like the RAM, the ROM, the storage, secondary storage, so that for any instruction to be sent on the secondary storage, there is a bus for that, and there's a bus for they are called with some different names for that. Then we also have inside the same CPU what we call the clock. The clock will help us to synchronize operation and determine processing speeds. The modern day CPU architecture has evolved to include multiple processing cores and extensive cache memories and also specialized instruction sets. This advancement has allowed for parallel processing. Parallel processing meaning that we process different processes at the same time, and it has led to optimization of specific tasks like graphic rendering and artificial intelligence computation. Now, CPU in the computing ecosystem. Now, how do we locate the CPU in the computing ecosystem? Now, at the top, the physical layer, where we have the hardware level, at the hardware level or the physical hardware, we have the electronic components that makes up the computer. Then these electronic components, on top of it, will have what we call the CPU or the processing hardware. And the work of the CPU on this motherboard will execute instruction and perform calculations. Then this CPU is going not to work by its own. It is going to get instructions from the user, and the user will always interact with what we call a software. And this type of a software is a system software that is called the operating system, which will manage the hardware resources and provide the services or give instructions that are required to be processed by the CPU. Then after which, we have the applications, which are the programs that are running on a platform called the operating system. They are the softwares that the user use. They are used to perform the end user activities. They are the softwares that we talk about, the application softwares. Example, Microsoft Excel, Access, and many other type of softwares. Now, this CPU works within a broader computing ecosystem by interacting with the memory. They enable storage, and they also enable input-output devices to perform input-output operations and other components. While it serves as the brain of the computer, its effectiveness depends on the entire system architecture and the softwares that directs it to do the operation. So get note of that. That being said, I want to say thank you for taking your time to understand the concept of CPU and the processing unit. See you in the next class, and God bless you all. Ensure you do all the activities in this section. God bless you so much.